Technical Graphics, Axonometric Projection. So what we'll have here today, we're going to do an axonometric projection example in the isometric form. We're going to do an L block. As you can see, there are the measurements and the views are indicated. Elevation in the direction of arrow A and end view in the direction of arrow B. So how might this look? So ultimately we will have this type of arrangement where we have our axonometric plane in the center, our vertical plane here on the right, and our end vertical plane here on the left. And that will contain here our elevation, our end view, which combine to give us our axonometric view. So we'll get to it. Okay, welcome everybody. We're going to do an axonometric projection, an isometric type, and we're going to do a simple L block exercise here today. Now, with axonometric projection there are three types. We can have isometric, we can have dimetric, and we can have trimetric. Now, at junior cert level we only ever deal with the isometric type. And what is the difference between these three types? Well, the isometric type axonometric projection will have an axonometric plane that is based on an equilateral triangle, a triangle with all sides and angles that are equal. A dimetric projection is based on an isosceles triangle, where we have two angles and two lengths of the axonometric plane the same size. And then finally the trimetric projection, which is where we have a scalene triangle, where all the angles and sides are different in the axonometric plane triangle. Okay, so we want to familiarize ourselves again with planes here. So we're going to start off in the middle with what's called the axonometric plane. And what we're going to do in this example is we're just going to work two views. We're going to work an elevation, which will be based on the vertical plane over here, and then we're going to work on the end view, which is going to be in the end vertical plane, which will be located here. Now, there is a third view that we include as well, depending on the variation of the question, and that will be the plan view, which would be down here in the plan view plane, the horizontal plane. But for this example today, we don't need the plan view. So we're just going to take two views, and this is normally the case with axonometric. Normally you only need to take two views to form your axonometric view. And what is that axonometric view going to be? Well, it's going to be a view that, based on 2D information in either of the views either side, when we combine the information we will get a 3D isometric view in the middle, and will be scaled down ever so slightly as well, in line with the projection. Okay, so I've located point 0 here on the page first. I've come down 160 and I've come in 200. Okay, so roughly to locate that point 0, and that's not always the case, and the page is not always landscape, it can be portrait as well. So I'm going to start off here and I'm going to draw a couple of lines very clearly first. Okay, from point O I'm going to draw a line straight up. It doesn't matter what length the line is, just draw a line straight up like so. Then from point O to the right I'm going to draw a 30-degree line. So it's important you're using the right set square here, and again the length of that line does not matter. And then finally from point O once again, in the heading in the left, we're going to go 30 degrees. Again, it doesn't matter what length the line is. So what are these lines? We have the X, Y, and Z axis lines. Okay, and these axis lines, you can imagine now looking into the very corner point of a room. Okay, and that's the very corner point. And along line Z we have the ground line, might be the skirting board. Likewise for X, and this might be the corner of the wall running up. So it's always nice to visualize that when we begin axonometric projection, because having a reference for those planes in terms of real life will help us to develop our solution. So imagine just looking into the corner of a room. Now, within this space here, I want to create my axonometric plane. Okay, and as we are doing an isometric type, that axonometric plane is going to be an equilateral triangle. And we can make the triangle in here any size we like. Okay, we can make it in terms of length. Alright, because if it's equilateral all the lengths will be the same. normally speaking, what I do with my set square or my t-square, if I have the measurements here, if I have my set square, it doesn't matter, either or. What I'll do is I will get my set square, for example, and I'll go normally 80 millimeters long on my triangle. Now I'm not going to draw it like that just now. What I'm going to do is I'm going to mark the points first. So starting with 0 there on the Z line and 80 there on the X line. Okay, so I have two little dots there. Now I'll join them with my t-square because I want that line to be perfectly straight. Okay, now if that line's 80 millimeters long, okay, and it's an equilateral triangle, that means we're going to simply have a line on this triangle, the axonometric plane, that's going to be 80 millimeters long. Okay, on the other side and on the other side. And of course, any triangle contains 180 degrees. So, if we have three equal angles, we divide 3 into 180 and we get 60. So I use my 60 degrees here from the point on the x-axis line. I'm going to draw a line at 60 degrees to hit the y-axis line, like so. And then likewise then, from the z-axis, the point there, I'll draw another 60 degree line. And of course they will meet there at the top because it will be an equilateral triangle. So if you want to visualize that in terms of the triangle now being like a sheet of triangular glass lying into the corner of the room, okay, as we've explained just previously. So I'm going to label these points here now on the triangle A, B and C. Now we don't always have to do this. In fact, there are shorter ways of doing this. If you were to look at the exam questions, they don't actually include the triangular planes. They include the axis lines, alright, but for all drawing purposes moving forward with axonometric from junior to leaving cert, I think it's important that we know how to set up the planes correctly and that we understand for each type, be it isometric, dimetric or trimetric, that we know what type of plane we need in the middle. Okay? Now, next thing we're going to do is we're going to set up our vertical plane over here on the side, which is going to contain our elevation. So in order to do that, I'm going to use my 60-30 degree set square. Okay, I'm going to line project out at, I'm going to project out at 30 degrees, okay, from point B. Now when I do that, I can go out as far as I like. In this case, I'm just going to go out about 100 millimeters. Okay, I think it gives us enough space. Alright, and I'll mark a point there. So out 100 at 30 degrees and mark a point. Now go to point C and do exactly the same thing. Go out 100 and mark a point. Very important they're the same length. Okay, now what I want to do, using my 60 degree line, I want to connect the two end points of those lines. Like so. So I have two 30 degree lines going out 100 millimeters long, and then I have a 60 degree line joining them across the end. Of course, the more technical way to explain that would be that the projection lines going out are at the same angle as the z-axis because we are looking out in this direction, and then the line at the end there is parallel to the line CB. Okay? Now what we want to do is we want to project out point O. Okay, well AO if you want to call it. So we're going to extend that line, the z-axis line out, all the way out to hit out here. Now once we have that, we're going to take our compass, and what we're going to do, and keep all of this work light for the time being. If mine's a little bit heavier, it's because I want to make it visible on the projector. Okay, so putting the point of my compass on where the line AO extends out to hit the end line here, I put the compass on and I stretch it out to either the point below or the point above. That doesn't matter. Okay? And I'm going to swing an arc. And again, keep that arc nice and neat, nice and clear. It doesn't have to be too heavy. Make sure your compass lead is sharp. So what I'm going to do there now is I'm going to, where that semicircle intersects the line AO heading out, or the z-axis if you want to call it, we're going to mark a point there. Okay? And I'm going to highlight the other points, like so. So I have 3 points out here now that I'm going to join up. But just before we join them up, we're going to label them once more. So that's point B. Why is that point B? Because that's B heading out there. A is going to be here. and then C is going to be here. So essentially what we're getting is we are getting out here the vertical plane, alright, but the vertical plane is essentially an elevation view of this 3D axonometric plane inside here. So what I do is I now connect C to A and A to B, okay? And likewise then I can also just slightly highlight back to C. I'll do that once more there. Didn't really draw through that well. Like so. Okay. So we have the axonometric plane here. And I'll just write it into the side. Axonometric, axon plane. I'll call this the vertical plane up here. Vert plane. Okay, so that we know what the planes are when we're looking back. Now within this plane we're going to contain our elevation. Now you notice that that plane is kind of tilted off at an angle, and you will notice that when you get an exam question, alright, you'll see this. Okay, you won't be given the plane, but we'll make a point of referencing the angle that is here. So let's say I take my marker here. What is about that? Now you don't have to do this, but I'll just point out that the angle that this plane is at, put the compass on A here, I'm just going to swing a little arc here so I can indicate the angle. Okay, the angle between the vertical line here and the line AC is going to be 15 degrees. Okay, so if I measure that now, okay, if I put my protractor on the vertical line, lining up 0 there like that, and I measure the angle of the line AC, okay, and remember the center point of the protractor is at point A, I get a 15 degree line. Okay, so that's going to be 15 degrees always in the isometric axonometric version. Now we can put 15 degrees in there. Just so you're familiar with that, when you look back at an exam question, you see that 15 degrees wrote down. You'll understand what it is then. Okay? Now, we're going to do exactly the same thing out the other side. So I won't delay too much in the explanations here. I'm going to mark out a line from A here now, 30 degrees, 100 millimeters long. I'm going to mark out a line from point C, 30 degrees, 100 millimeters long. And then I'm going to join them over at the end with a 60 degree line, like so. Now what I'm going to do is I'm going to take out, looking along the x-axis and lining up with the point B and O, I'm going to project out a line, like so, at 30 degrees. Where that point hits out there, I'm going to get my compass. All of this is probably becoming self-evident now, and once you get the hang of this topic, it's real easy to set it up. Okay, so you can see there now I have my compass, and what I'm going to do is I'm going to swing my semicircle. Okay, where my semicircle intersects the line that comes from the x-axis containing B and O, I'm going to contain that. So there's point B in this case, because B is lining up there, and here's A here, and here is point C. Once I have those 3 points, and I'm happy enough with those, I will then join them up. C to B, B to A, and if you want to highlight it again, A back to C. Okay. So that is our, we'll call that our end vert plane. End vertical plane. Okay. And what I'll do is I'll add a few directional arrows just to show you where those lines were going out, like so. And the key thing here really is having your 60 degree, 30 degree set square. Okay? So that end vertical plane is going to contain our end view. Alright? And what we're going to do is we're going to draw in our elevation, our end view, and we're going to combine it here to get a 3D view. So, one question I always get is when we draw an object into either of the planes either side, or if we have the plan view below, does the object have to match up with the size of the triangle? No, it doesn't. Whatever the size is, well, that's the size. So don't worry about that. What these planes give us is they give us the angle that we need. So we could have an object that's much bigger than the plane that we've just drawn, and that's fine, so long as we are keeping everything in line with the angles of the line AC and AB, and likewise on the other side. So don't be worrying about the size of the object. So for example, we're going to draw an L block, okay, and we're going to make this L block 50. It's going to be a cube, and then we're going to take a little bit out of it, and that will give us our L shape. So it's going to be 50 by 50 in terms of width and height. So we'll deal with that for the moment. So from point A here, what I am going to do is I am going to mark 50 millimeters. Okay, so you see the way I'm lining up on the line AB here. Okay, 0 here, and I'm going to mark out 50. And you can see in this example here that I'm drawing that my L block is going to be a little bit smaller than my triangle. Doesn't matter. Whatever it is, that's what it is. So in that case there, what I'm going to do is I'm going to heavy in that line, because that's the bottom line. It is going to be a solid line, so I'll heavy that in so we can see it going along. So it's going to be 50 there. Okay? Now, I'm going to go from point A up, place my set square, 0 there, and I'm lining the set square up along with the line AC. And I'm going to mark 50 once again. Okay? And I'm going to make that a heavy line. Okay? And I'll just make it extra heavy so you can see it there. Alright. So, I have 50 marked here, I have 50 marked here. Now what I need to use is my sliding set square method. Some of you might have an adjustable set square. If you have that, you can offset the angle to the relevant angles that are for the lines AB and AC and so on. But for purpose of demonstrating our normal sliding set squares, I'll do that method. So what I do here when I'm doing my sliding set squares, I'm going to focus on bringing a line straight across from the top here now. Okay? Because it's not going to be a horizontal line. It's the same angle as the line AB. So what I do is I line up one of my set squares with the line AB, like so. Okay? Now, a handy thing to do is line up 0 with A there, line up the set square with the line AB, and then put the other set square just to the side of it, like so. This one gets held down, okay, nice and secure, okay, and then what I do is I slide point O all the way up there to the top point that I marked out, the 50 millimeter point I marked out. So what I'm going to do from there is I'm going to draw a light construction line. Okay, don't draw anything heavy here, 50 millimeters long. Okay, now what I want to do from the point here is I want to draw a line straight up, but that line is not going to be a vertical line, it's going to be at the same angle as the line AC. So this time what I do is I get my set square, I line 0 up with A, line it up with the line AC like so, okay, and place my other set square underneath. Now I'll hold firm on this one here. Alright, this one is going to stay and my main set square is going to slide over. So as you can see there, I'm sliding it all the way over, and now what I'm going to do is that point I marked out 50 millimeters, I'm going to bring that on up, okay, as a construction line, nice and light. So we'll just highlight what's parallel to what. So AB here and that line, they're parallel, and then we'll have the line AC here and the line here parallel, okay. So that's just to show you what's parallel and what's not. Now, what I'll do here is I want to divide this square into 4 parts here. So I'm going to go 25 there, mark a point, and I'm going to go 25 up from point A on the line AC, like so. And I'm going to draw 2 more construction lines, okay? I'm going to line up with the line AC here. Make sure that you're good and accurate with lining up. We want that to be as good as we can get it. Construction line there. Now, line up with the line AB. And I don't have to line 0 up this time because I have the points marked here and I just want to slide up and draw the line across. Okay. Now, I can heavy in my L shape simply by connecting the dots. So there, to there, to there, and back to there. So you can see I'm going to go like that. Alright? So essentially it's like the same way you'd be drawing orthographic, except we're just drawing it kind of off at an angle. And of course this is going to be our elevation. Okay, and then here we go here. Just to heavy it. Now, just to make that a little bit clearer, I'll take a little bit of colour and I will colour in that elevation just with a little bit of yellow. Just so it's nice and clear that you can differentiate the shape there and so on. And of course, I will label the view in a moment there once I have a little bit of rendering done. And again, when I'm rendering, slightly heavy toward the border lines and lighter in the middle of the surface, okay? Do not use markers, do not heavy over the lines with markers or anything like that, okay? This is the elevation. And that's contained on the vertical plane. Now, for the end view, we're going to repeat that process, okay? So from B, out on the line AB, I'm going to mark 50. Okay, and from B on the line BC, I'm going to mark up 50, like so. Now, once I have that done, okay, we're back to the sliding set squares again. So we're going to line up with the line AB, and I'm putting 0 on the point that I marked out 50 mil, and I'm making sure that my set square is good and accurate there, lined up with the line, and I'm going to slide up to the point I marked 50 millimeters up here. Okay. Draw a light construction line, not heavy, light. Then I'm going to line up with point B on the line BC, which is this line here, with the set square. Place the other set square underneath, and then I'm going to slide over to the 50 millimeter point I marked out from B on the line AB. And again, I'm going to draw another construction line. So, just to point out, that line there and that line there, they're parallel. And this line here and this line here, they're parallel. Now, in this view, the end view, we're not going to see the L profile. What we're going to see essentially is what looks like a square with a line through the middle of it, okay? And that'll be representing the two surfaces we would see if we were looking at the end view of this particular object. So what I need to do is I need to apply one more measurement. So from point B up, I'm going to mark 25 millimeters on the line BC. Okay? So I've marked a point there. You guessed it, I'm going to line up now, okay, with the line AB. Using my sliding set squares now, I'm going to slide up to that point I just marked, and again a light construction line like so. So once I have that, what I can do is I can heavy in. So there we go there, that's one side, that's the other. And in this case, you don't need to use the sliding set squares to heavy in. You can just take your set square, line up with the lines, the construction lines you've already drawn, and heavy them in. Okay. So this essentially is our end view. And I'll apply a bit of colour there in a moment. Now, so with the end view, all good there. A little bit of colour. I'll use a different colour on the end view just to differentiate it from the elevation, so that we come to understanding what's what, we'll be able to differentiate things by the little bit of colour, and the colour really is a visual aid. It's not required in an exam or anything like that. Alright, we just want to shade slightly heavy toward the border lines, light in the middle, and that gives us a nice presented view. Now what I want to do is I want to combine the information from both of these views into the middle here. And remember, the angle we projected out was 30 degrees. So now we're going to bring all the points from both of these views back in at 30 degrees. Alright? So very important that you're using the correct set square in this case. Now, what I'm going to do is I'm going to label this front surface here. Now you're saying, oh, front surface. Well, you think of this being eventually a 3D object. Alright, this is just the elevation, the front face. So I'm going to label the front face, and then what we're going to do is we're going to we're going to label over here the front face points, alright, and I'm going to show you how that will form in the 3D view. Okay, so when we're labeling, alright, we're going to start here at A, alright, because point A isn't a point on the object. Point A is a point on the plane. So where A is, I'm going to write 1. 1. Okay? This point here, we'll call it 2. We'll call this one 3. We'll call this one here 4. We'll write it in there on the surface. We'll call this point 5. And this one here point 6. Okay? Now, all of these points we see here, they're all actually contained on this side of the object in the end view. Alright? You can imagine my elevation is me actually looking in from the side here. Alright? When I say the side, that's actually the front. Okay? So, when I label that, alright, what I'm going to see on the ground here is you're going to see 6.6 in front of point 1 here on the ground. So you're going to see 6 and 1. 6 and 1. Okay? Right here. Then I'm going to see 5 in front of 4 right here. So that'll be 5 in front of 4 right there. And then I'm going to see 3 in front of 2 right here. 3 in front of 2. Okay, 3 in front of 2. Now we could go and say, right, let's label the back points. Okay, let's do that. So let's say we go, we call this 7 then. Where 1 is, we'll go 7. Okay. Where 2 is, we'll go 8. Where 3 is, we'll go 9. And you see, I'm always placing that second number to the right of the first number. Why? Because the first number is the one in front, the second number is the one behind. So 3 in front of 9, 4 in front of 10, 5 in front of 11, and 6 in front of 12. So as I look at this line here now, all those points I have just wrote out there for the back side of the L block are going to be contained on this line here. So we're going to have 12 in front of 7 on the ground. So 12 in front of 7. I'll write that in there. Then I'll have an 11 in front of 10. 11 in front of 10. And then I'll have 9 in front of 8. 9 in front of 8. Now, we don't always have to label, but from a starting point, when you're trying to get your head around this, take the time to label, you know, and to understand where the points are coming from, so that when you do connect them up, that you're exact in your connections. And then after a couple of these drawings, you'll find they're rather intuitive, that you're going to be able to look at them and you're going to be able to do them almost without labeling. Okay? So, now we're going to do the projection lines back into the axonometric plane. Okay? And we will do that using, we'll use a little bit of blue. Okay, so, for example, let's focus on point 1. Okay? From the end view, 30 degrees. Okay? Well, we focus on the points 1 and 6 here. So I'm going to take a line, and don't worry about the length of these lines. Okay? Just draw them on. Now, take a line back in at 30 degrees. Okay? Like so. You can see that line coming back in. And I'll put a directional arrow on that line just to indicate that it's travelling back in. Now, where do I get 6 and 1? Well, if you see here, point 1 is already contained on a 30 degree line, the line that was brought out by A, but we'll just heavy back in, and we can actually locate point 1 right here. And when I locate a point, I will immediately mark it 1. Okay? So there's 1 there. Point 6, we'll bring the line out for point 6. So 30 degrees back from the elevation to intersect. And again, I will apply a little arrow there just to show the direction of the line is coming back in at 30 degrees, and it intersects the line I brought from the end view. And we'll call that there, that point, point 6. Okay? Of course, there are a lot of shortcuts that we can use at times, but we're just going to do it kind of by the book for the moment. Now we'll go to points 5 and 4. Okay? Well, actually, funny enough, what we can do here while we're at it is we can mark points 12 and 7. Okay, so you will see here that there's a line coming in already for point 12. Okay, it's on that line we projected out in the first place. And you can see the line for 12, or the point 12, is contained on the line we just brought for 6. So what we can do there is just mark that point. Okay, and that'll be point 12. I'll just put it slightly out to the side here. There's 12 right there. And point 7 is going to be in right at point 0. Okay, so we'll just put 7 right there. Okay, so now I have the 4 points that are on the ground. 1, 6, 12 and 7. 1, 6, 12 and 7. 1, 6, 12 and 7. Okay, so that then completes the ground points. Now what we want to do is focus on the next set of points. So we're going to go 5 and 4 here. Okay, so I'm going to go through these a bit more quickly. Again, line up my 30-degree set square. Make sure it's perfectly set on the T-square. Okay, and we're going to bring in a line at 30 degrees. Okay, bring it on in. Don't worry about the length of the line. Okay, just bring it on in. Now what I'm going to do is I'm going to bring in point 5 and 4. So there's point 5 brought in at 30 degrees, and here's point 4. That line actually lines up with the previous line we had. Okay, and we bring that on in. So in fact we have our point 5 there, and then we have our point 4 here. I'll just write point 4 right there. Okay, and you might say, well, that point 4 is on the ground, it's on the Z line. No, it just coincidentally lines up with the Z line, alright, or the line A. So it's actually up off the ground here on the front. Now, there are 2 more points that we can represent with these lines. We have 11 and 10. Okay, 11 and 10 are located on the lines for 5 and 4 that we just brought in. But we do need to bring it in from the end view. So what we'll do there is we'll bring in 11 and 10. Like so. Okay, now once we bring that line at 30 degrees in, we're going to mark point 11. Why is that 11? Well, 11 meets 11. 10 now is going to meet 10 right here. Okay, then what we're going to do now is we're going to focus on the next set of points. We're going to go to the top surface here. Okay, and in fact we've only 4 more points to bring. So that's points 2 and 8 and 3 and 9. So again, we head out to our end view here. We're going to bring a line in there, 30 degrees. Now this point 3 and 2 here in the back corner is going to line up again with the line, the x-axis line. Okay, and it'll line up with point B and so on, which is 12 and 7. And that's just because we have a square object here and it's just lining up. Okay, so we can assume that line 3, 2 all the way through here. Now what we're going to do is we're going to take points 3 and 2 here from the elevation. So I take point 3 and I'm going to stop it on the line that I just brought, that is there anyway. Okay, we'll call that 3. Okay, and then I'm going to bring point 2, 30 degrees again from the corner point here, like so. There's point 2. Now we have 2 more points, 9 and 8. Where are they going? So points 9 and 8, we are going to take a line at 30 degrees, and where it intersects the 2 lines that we brought in at 30 degrees already for points 3 and 2, they will be the points for 9 and 8. So there's point 9, or sorry, that's point 8 right there, and this will be point 9 right here. So I now have all my points located, alright, and of course there are quicker ways to do this, but I am just demonstrating this particular method for the moment. Okay, now what I'm going to do is I'm going to join up those points. Okay, so I'm going to join all the vertical points first, 6 to 5, 12 to 11, 1 to 2. Okay, there's hidden detail in at the back. Okay, we'll leave that out at the moment. So these points, we're just going to focus on the ones we can see for the moment. 4 to 3, 10 to 9, and you can start to see the shape developing here. Now, using the 30 degree side of my set square using the t-square, I'm going to line up 1 and 6, draw a line. 4 and 5, draw a line. 3 and 2, draw a line. Now you can see the L profile there, yeah? We're then going to go over there, we'll join 11 and 10, okay? We'll join 9 and 8. And you can see the back side now, shape. Then what we'll do is we'll heavy the lines across from 6 to 12. Again, 30 degrees, okay? 5 to 11. 4 to 10. 3 to 9. And 2 to 8. Like so. And you can actually see there now that I have the 3D object in its position in the axonometric plane. Now I'll put a little bit of hidden detail there in to represent the back lines. I think it's always a nice touch. It shows that you understand what's there, and in some cases you might have to do it. And then likewise for the line in on the ground at the back, we'll put in an hidden detail, always with a dashed line, okay, a broken line. And of course we have a bit of a heavy line here, so we'll only see a little bit of that line there on that side, okay, like so. Now what I'll do then to finally give you a visual on this is we'll apply a little bit of colour, and like so. So this is going to be the yellow surface representing the elevation, like so. Okay, so that's that surface. Then we go to the end view. Okay, that's going to be blue there. That'll be blue. And this one here, this surface here, will also be blue. Okay, so that would be our end view. And then of course we have two other surfaces there that are immediately visible to us. Alright, and if we were to have included a third plane, the horizontal plane, below, and drew the plan view of the object, well then we would see the pink colours. Okay, but as I was saying in the beginning, it's normally the case where we only need to draw two views to obtain the 3D object in the middle. Okay, and we don't want to be putting any unnecessary work on ourselves, doing any additional views when the information we need is already contained in two views. Okay, so drawing is about efficiency too. It's not about putting the maximum amount of work into it. So this is our axonometric isometric projection. Now, I hope you found that useful, and of course I'll be doing plenty more videos, so remember to click and subscribe for more content,